Hi, welcome to module 38. In this module what we are going to do is, we have tied together a lot of things. As a picture we had what the controller is supposed to look like as a black box. We also had almost a grey box description of what a data path must be, and then we had this top level module itself. So let us look at the top level module for a little while. So this is the top level module. The top level module has clock and reset, and it has three inputs: input 1, input 2 and go, and output and done. So one of the things that we have not talked about so far is what is the size of these inputs, because I am supposed to be calculating GCD of numbers, right, and numbers have width, as in the number of bits required to represent the digital the decimal value. We need to decide that. So one of the things that we will assume is input 1, input 2 and output, we will assume that they are all 8-bit values. So these three we will assume are 8-bit, go is a 1-bit value and done is a 1-bit value. So the first thing we are going to do is we are going to write a module description for the top level module, and this is so what this top level module needed was actually two different modules. So one of the modules is the controller and one of the modules is the data path, and what the top level module in turn will have is a set of things. So let's start the description. What we need is we are going to instantiate a controller, we are going to instantiate a data path, and we are going to connect all of them together with this interface description. And so right now this is a top down view of what we are going to do, and this gives us a small problem at a time to deal with. So I am not worried about all the things that is going to go into the data path itself or how the controller is going to be written up. I am first going to write what the overall system is going to look like. So this I am going to do as a Verilog module itself. So let us see the design description for a GCD machine. So I am going to define a machine called GCD machine, and the GCD machine is going to have several things. So it is supposed to have clock, reset and what not, right. So I am going to put all of those in. So I have clock, reset, and I am going to have three inputs, an input called go, an input called in1 and another input called in2, and we are going to have two outputs, one output called out and an output called done, and I have to specify what each of these things are. So clock and reset are just inputs, and the in1, so clock, reset and go are all single bit inputs, so I'll specify them as is. In1 and in2 are again inputs, but I am going to specify them as 8-bit values. Then there is output out, and there is also an output called done. So done is a single bit output, and the actual output it could be a 8-bit output. So if I give the same number which are both 8-bit numbers, then I may get the result which is a 8-bit number. So I have that. So this takes care of the module interface that we need for the GCD machine. Now let us go back and look at the picture for the internal diagram. So the internal diagram says the controller should be connected to the data path. There are a few signals that are going back and forth between the controller and the data path. The input of the go, the input go of the design should go to the controller. The input, then there is clock and reset, which is supposed to go to both the controller and the data path, and the output is supposed to come from the data path, done is supposed to come from the controller, all these little things that we needed. So this is a slightly more detailed picture of what we needed. What I am going to do is I am going to take this picture and I am going to write Verilog description based on this. So what I already have is a boundary view of what the topmost design module is supposed to have. Now I am going to look at the internals. So the clock that is coming from the external world, reset that is coming from the external world, go that is coming from the external world and so on should all go to the controller. So these are the three inputs that will go to the controller. Then there are three more inputs, namely A greater than B, A equal to B and A less than B, which will also come into the controller, that is going to come from the data path, and these 4 should go out of the data path. So if I imagine this as I am going to buy 2 chips, one called controller, one called data path, I will still need wires to connect all of them. So let us look at all the wires that are needed. So controller will need 4 wires, A select, B select, A load, B load, to connect to the data path. Then we will need 4 more wires, namely A greater than B, A equal to B, A less than B and output enable. So we will need 8 wires so far to take care of various connections between the controller and the data path. So let us do those declarations first. So what are the different things that we need? So I will have a wire for A greater than B, A equal to B and A less than B. So I have 3 wires for that. Then I will need 4 wires that are going from the controller to the data path. So that is A load, A enable or A select, I think I called it, then B load and B select, right. So this takes care of connections that are going out of the controller, and one more signal that is supposed to come out of the controller is output enable. So this, again if you look at the picture, we have taken care of these wire declarations, right. All these wire declarations are taken care of. Now let us go and look at how the design description is going to be. So let us look at the controller for now. The controller is supposed to take these as inputs and give these as outputs. That is exactly what I am going to do. So I am going to call my controller as controller later, and this is instantiation of a controller. So I do not even have the design for the controller yet, remember. All I am doing is I am saying the controller is supposed to have all these connections, and I will assume that somebody is going to design the controller and give it to me, and this controller will have this interface. So what is the interface? I am also going to design the interface right now. So it is supposed to take a clock, a reset, a go, and it is supposed to take A greater than B, A equal to B, A less than B. So these are the inputs that it is taking. So I am going to specify all of those. Then I am going to put all the outputs that it is giving out, A load, B load, let us say A select and B select. So these are some of the outputs. Then it's going to give an output enable, and it's going to have a done signal, right. So without actually designing what the module is, I just looked at what is the interface is supposed to have. I put all the things that are needed, clock, reset, go, then various other inputs, various outputs, output enable, done. In some order I have specified all of those. So what I have to do is, when I design the controller, I have to take care of the order that I have designed here. So this kind of top down kind of design is helpful and necessary many times, because you have a picture of what the whole thing is supposed to look like, and then it gives you time and it gives you the flexibility to go and reorder whatever you want inside. You can do the data path in a slightly different way, but the data path still needs all these interface connections. Maybe the subtractor that I am going to put in, I can think about how to design the subtractor later, how to do the comparator later and so on, but these are all the different things that it is supposed to take. And one thing you can notice is the controller, it is not exposing the state registers. We do not need that. We need the controller to do the job of controlling the data path, and the state machine that we did there, we are not supposed to expose the state machine itself to the world. All we need is the outputs of the state machine, the inputs of the state machine. The state register itself need not be exposed. So you do not see it in the picture here, you do not see it in the Verilog description either. So now let us go and do a data path. So I am going to see what the data path is supposed to have. So I am going to call my data path D1. Let us again look at the picture here. What are all the different things? Implicitly there is a clock and reset that is supposed to come in. There are 2 inputs, in1 and in2, and it is supposed to take all these as inputs, give all these as outputs and whatnot, right. So I am going to put all of those out. So there is a clock and a reset, these are supposed to come in as inputs. Then there is a select, a B select, so these are supposed to be going in as inputs. Then A load, B load are also supposed to go in as inputs. Then it is supposed to give 3 outputs, A greater than B, A equal to B and A less than B, and it has another input line called output enable. And finally, the actual output itself is supposed to come from the data path and not the controller. So if you go and look at the output, that is called out, so I am going to put that here. And this actually finishes the module description for the top level module. So let us see the top level module completely. So it has this module GCD machine, it has clock, reset, go, input 1, input 2, output and done. It has these as inputs, these as outputs, all these other things are wires, and this is supposed to instantiate a controller which will be designed later. It is supposed to instantiate a data path which is also designed later, and that is pretty much it, and after that we have an end module, that is pretty much it. So there is no reason why the order in which the wires are given here are supposed to be maintained in data path, there is nothing like that. So all we need is the name connections. So here if you notice this A greater than B, A equal, A less than B, and then the load signals and then the select signals are given in that order. However, here the select signals are before the load signals and the load signals are before the greater than, equal to and so on. So this is just names of the wires, as long as you tell this in the Verilog description that this pin from this controller is supposed to connect to this pin of this data path element and so on, that is all you need, you do not need more than that. So we have that here. So far we have the design description for the controller itself. So I am going to try and do something similar for the data path. So let us again look at the picture for data path. Let us see the data paths picture. So the data path has several things. It has 2 subtractors, 2 multiplexers, 3 registers and a comparator, and there is a lot of wiring that is supposed to be connected, connecting all of these. So the next thing I am going to do is I am going to try and write the data path for this. So let me save this. So I am going to write data path.v. So let us see what are all the different things that the data path itself needs. So the data path has all these as the interface. We actually had the interface earlier, so we had assumed that the data path is going to have this kind of an interface. So I will just copy that right now. I will copy this. So now I am going to do the modifications to it. So I have a module called data path, it is not an instance, so I will delete the instance name, and this is the description that the data path is supposed to have. So as an interface, the data path has all these things. Now again I have to specify which are all the inputs and which are all the outputs and so on, and so from the data path's point of view we know these things. Let's do that first. Clock and reset are single bit inputs that are supposed to come in, so we have that. Then A select, B select, A load, B load again are all inputs that are coming in. So A select, B select, A load and B load again are inputs. Then let us look at the equal to, greater than and less than. So those are 3 outputs. So that is supposed to be an output. A greater than B, A equals to B and A less than B, we have them as outputs. There is an input line that is coming called output enable, and there is another output which is actually a 8 bit output. In this case it is supposed to be an 8 bit output. So, I will put that in. All right. So, let us go and look at the design once more. So, the design has various things, and so that oh, I forgot one small thing here. So, the data path is also supposed to take the input 1 and input 2. I forgot that here. So, these are two inputs which are the data inputs. I forgot that in the design file. So, I have put that in now. In the data path again they will have two inputs. So, there are two inputs, input 7:0, input 1 and input 2. So, yeah, this is the data and I missed that. So, again now let us go and look at the picture for the data path itself. So, we have several things here. So, we have two subtractors, 3 registers, 1 comparator and 2 multiplexers, but before we get into what these are, we need a few more things. First of all, there are wires that are connecting different submodules. Even if I instantiate 2 subtractors, 2 multiplexers, 2 registers and so on, there is lots of internal wiring. So, I will need names for all of these wires. So, we will decide on that. So, as we go we will decide on those things, and one of the other things that we will need is we need to specify all the connections and put all of them together. So, let us look at the hardware modules. I will have 1, 2, 3, 4, 5, 6, 7, 8. So, I will have 8 instantiations of different kinds of modules. So, there will be 2 instantiations of subtractor, 2 instantiations of multiplexer, 3 instantiations of registers and 1 instantiation of a comparator, and we will have all the wiring that is supposed to be connecting all of them out. So, let us figure this out. So, the first thing I am going to do is I am going to take the wires. So, let us see the wires. So, input 1 already has a name, but this one will need wiring. This signal here will need name, this signal here coming out of the subtractor will need a name, and this coming out of a mux will need a name. So, these two will need a name, and these two going to the comparator will need a name, and that is pretty much all the names that we need. So, we need 6 names. So, this wire bundle, these 2 wire bundles, and actually this and this are the same wire bundle. So, even though it is drawn as different things, it is actually the same wire bundle and this. So, for all of these I need 6 wire names, and I am going to put wire names now. So, I will need 6 wire bundles. So, wire 7:0, and for the 6 wire bundles I am going to call them TA, TB, TC, TD, TD and TF. These are the 6 wire bundles that I need. So, I use that symbol T to indicate that it is actually just temporary, and A and B and C and D and so on are all for, so maybe I can make it slightly better. So, I will make TA in, TB in, these are inputs to the registers A and B, then TA out and TB out are going to be outputs that is coming from the registers. We can see that here. So, there is TA in, TB in, TA out and TB out, and out of the subtractors whatever is coming out. So, I am going to call them some T1 and T2. So, those are some temporary names. So, I will not assign names for them, I will just call them T1 and T2. So, this is what we have so far. We still have to connect all of them together, and in doing so I am going to do, I am going to keep this picture in mind. So, we will do that in the next module. So far what we have is, we have done the module description or the interface description for the data path. We will need to put in the internal details of the data path. So, I will do that in the next lecture module.